Hey YouTube, in this video we're going to talk about the properties of the real number system under the four operations that we use often, which are addition, subtraction, multiplication, and division. You have noticed up in this point in your life, I'm sure, that when you operate on numbers, certain properties apply. So for example, with addition, we could say that 4 plus 3 is the same thing as 3 plus 4. Whoops. Meant to write an equal sign there. It's the same thing as 3 plus 4. These properties are so special that they get their own names, and the good news is that their names, they make sense, but we want to know what those properties are called because we use them often enough. So we're going to start over here really quickly. This table, we just want to make sense of what's going on, but we say the associative property. If we allow a, b, and c to be some real numbers, then we could say, noticing here, we'd say a plus the quantity b plus c is the same thing as the quantity a plus b plus c, and of course we could substitute anything we want in for a, b, and c respectively, but you notice that this property always holds true. We refer to this as the associative property because in the first instance here we would have evaluated b plus c and then added that to a. In the second case we would have added a plus b and then added that to c. Basically it doesn't matter what order we do this in, and this works with addition and multiplication. So it doesn't really matter which order you do it in, so long as you pick a place to start and go. Okay. The commutative property, you've seen this one before. It's the one we listed on the right. Commutative. The base word of commutative is to commute. And if you've heard the word commute before, like I commute to work in the morning, it means to travel. Okay, travel. So we say under the operation of addition, okay, and multiplication, we say that statements or sentences are commutative. It doesn't matter what order you do those in. This only applies to addition and subtraction. We say that division and subtraction, or sorry, addition and multiplication, division and subtraction are not commutative. Okay, the identity property basically says this: there has to be a real number that, given this operation, so for instance here this is addition, I can do addition with some number and get the same number back. And so that number happens to be 0. We say it is the additive identity because when you add with 0, you get the same thing. And we call 1 the multiplicative identity because anything times 1 is still itself. So identity, think self. It stays the same. Whatever you started with will be the end when you get done operating. And then last but not least, the inverse property. Inverse, we kind of think of this as like backwards. It is the undoer, is what inverse means. But essentially what we're looking at here is this: we say, is there a number that would undo a positive a? And we say that is a negative a, or the opposite of that number. We say anything plus anti that thing gives us nothing left over. Or we could say it gives us the identity left over. And likewise, we say anything times its reciprocal. This is the same thing as saying this: a times 1 over a is the same statement as a divided by a, which is 1. But we can always collapse it back down to the identity element. And then last but not least, we say that this distributive property holds true with multiplication. It basically says we can distribute this multiplication throughout all of the terms of this sum and do our multiplication first and then addition, instead of doing our addition and then multiplication. So what I want to do is I want to consider this down here. Think about these properties up top and kind of what they illustrate, and look at these number sentences or statements below and try to match these with these properties up top. And you can pause the video. I'm going to go ahead and match them now, but we look at this first statement. We say 14 plus 7 is 7 plus 14. And of course, this is the same thing we had up here, but we say, what's really happening here? Well, these numbers from one side of the equation to the next, they moved around the operator, and we get the same thing. So since we get the same thing, and this is a special property here, we say that this is the we can move them property. We say the commutative property of addition. Letter B, we say 5 times 1/5 equals 1. And what we notice here is this: we took 5 kind of times the opposite of 5. We did multiplication to begin with. Well, times 1/5, that's the same thing as divide by 5. And so we get 1. So this is the undoer property. This is our inverse property of multiplication. We can absolutely see that is existent right here. Inverse property of multiplication. Next line, looks like here we say 5 times the quantity 3 plus 2 is 5 times 3 plus 5 times 2. Looks like we have distribution going on. The next line, anything times 1 is itself. In other words, 14, we operated on it with multiplication and some other, say, element here, and got 14 back. So this is the identity. It stayed the same. So this is our identity property. And last but not least, we say, well, I noticed that 3 plus 4 plus 5 is the same thing as 3 plus 4 plus 5. So I noticed the parentheses moved. So what we're doing is we're associating these differently. So this is the associative property, in this case, of addition. So really quickly, we do have 4 operators. I just want to be clear on this. Because we write a lot of number sentences using these properties as well, but we say we use the words sum, difference, product, and quotient respectively to denote addition, subtraction, multiplication, and division. So when you hear quotient, for example, I want you thinking division. So down here, what I've got is just some number sentences, okay, complete thoughts. What I want to do is I want to write some verbal models, which kind of shows up in algebra quite a bit. And then we're going to classify it either as a number statement or a sentence. So for example, it says the difference of -2 and 3 is -5. And the key word here being difference, we say, well, what's a difference? Sum, difference, product, quotient. This is subtraction. So we say the difference of -2 and 3 is -5. So we'd say -2, we can put that in parentheses even, and a difference with +3 is -5. And I notice that this is a complete thought. So this is a number sentence. We say number sentences are always like equations or inequalities. We say the next line, the quotient of -8 and 2/3 is -12. So we say quotient. This is division. So -8 and 2/3, and we have a quotient between the two things. We say this is -12. And then the last but not least, oh, and this is a sentence. This is a complete thought. And then the last one down here, we say the product of 4 and 5 and the difference of 10 and 5 summed. Now this one's a little bit different. You notice I put some commas in here, but we say the product of 4 and 5. That would be this right here. And the difference of 10 and 5. So we say 10 minus 5. This is a difference. Summed. And to be summed means I add these things together. So this would be what this expression looks like down here. This indeed is an expression. This is a statement. This is not a complete thought. This is like saying, I ate food and, and left it off. So a statement, we say a statement in math really quickly here, we refer to that as an expression. An expression is anything that it contains an algebraic, expression, but no equal sign, no greater than or equal to, none of that sort of stuff. Whereas a sentence is a complete thought and typically contains equal signs. Cheers.